So why bring science talks to a local parish? I think it comes down to access, opportunity, and service. Starting from the fact that at your local parish is probably juggling a bunch of efforts, and they have to prepare people for First Communion, confirmation, marriage. They have continuing education programs. Likely they have maybe a director of religious education, but in a lot of parishes, these programs are run largely or sometimes taught completely by volunteers. So bringing any content that's at that intersection and that serves the mission of those programs is doing service to your parish. Additionally, you have access to the people who are developing the content for these programs because they sit in the pews by you, or at least to your pastor who can direct you to them. As you might remember from your own experience with catechesis, whether you are a convert or crater Catholic as myself, these programs don't address issues of science and the faith. And there are efforts to integrate that exist, but often people come with this idea of the mythological warfare between science and the faith, either from the secular world or sometimes from faith communities that have very specific beliefs or ideas about this. So this is really an opportunity for us to extend the wonderful work that we've been talking about all weekend. Okay, so as far as topics go, at least in my case, and this hopefully resonates with people, I find a point of intersection of the science and scholarship that I'm interested in, and depending on the program and the target audience that you're thinking about, there might be some catechesis or Catholic social teaching or theology that's at the intersection there. But one of the things that I've found resonates with people a lot, especially kids and people in youth ministry, is just the fact that you're there. And it's a statement that you're a Catholic scientist wanting to do this type of work, and often people are interested in knowing about your faith journey. I do try to be very careful with this because, of course, it's something in science world at a level of science outreach, but it's not the same making an approximation to explain a black hole to a class of middle schoolers than it is to say something that you potentially did not study deeply enough in the theology or the social teaching of the church and lead someone in a wrong way in the faith, and you really don't want to do that. All right, so apart from what I said before, it's always good as scientists to help people demystify scientific concepts and evidence for the things that we do have solid evidence for. All right, so let's talk about time and eternity. I like subdividing this topic into sort of three categories of things: the fact that we exist in time, the fact that God exists in eternity, and how time and eternity, I'm going to use the word meet somehow in our Lord Jesus Christ. And when I start by explaining the physics that we know about time specifically, one of my favorite metaphors is 2D Jimmy. So 2D Jimmy is two-dimensional, and thus he cannot experience 3D. That doesn't mean he cannot understand 3D. Because if you want to show Jimmy a three-dimensional object, you can slide it through his plane of existence, and he's going to see a shape, and a shape, and a shape, and another shape. And thus, he's not going to be able to experience the third dimension, but he can for sure have some understanding of it. And this is actually very similar to how we experience time. Right? There are... Of course, there are realities that make the past and the future different. You know, the direction that you're looking tells you something about how entropy is going to behave and determinism and stuff like that. But the t equals now is experientially unique. And obviously you know where I'm going with this, which is that seeing time as a fourth dimension in our treatment of nature. And we have a lot of physical evidence to support that model and that way of understanding the universe, starting from special relativity. And so the concept essentially is that there is no the simultaneity of events is apparent when we are in an approximately similar reference frame, but it's not necessarily the case. So if the famous twin paradox from special relativity is that if one of the twins leaves in a spaceship as close to the speed of light for a few light years and back, they will have aged differently, and that is just a way to say the time will have passed differently in both frames of reference. And we actually have measurement on that. We've measured it with atomic clocks. And if you see, not only have we measured it with atomic clocks, but we have evidence from particle physics as well that this is the case. So muons, for example, are particles that are generated in the atmosphere. So you have cosmic ray particles, so essentially very high energy particles that come to the atmosphere. And muons get generated tens of kilometers, maybe it wouldn't need to be even more than 10 kilometers on the above us on the atmosphere for it to take too long for them to reach the ground, for them to remain alive. So we know this particle's half-life is 2.2 microseconds. But even if you're going at almost the speed of light, it's going to take you at least 10 times as much to reach the ground. But we detect in our particle detectors on the ground about 1 muon per centimeter squared per second, per minute on Earth. And so there's evidence from there, right there. But again, this is, we call it the theory of relativity, but we have evidence that this is how nature works. And the deep philosophical implication of this reality is that there's no such thing as simultaneity. There is no present moment that is happening right now and that exists right now, and the next present moment is coming, because not in every frame of reference that is different, the present moment and the way that elapses is different, right? And that's that's one of the reasons why our conceptualization of space-time, so of the universe as four-dimensional space-time, it's one of the reasons why it makes sense. If you think about, say, let's call it the container of the universe, and I think I used to think of it as the space where the universe is contained, let's call it that. Well, it turns out that container would be four-dimensional. And there are a couple implications of this that are cool. Well, not only is time part of creation, but all times have to exist. All moments of time have to exist. So you have this, let's say, four-dimensional container of the universe, and every moment of time and every place in space are all there. And there are a couple implications to the philosophy and the theology of that I'll get into. But space-time actually has a couple cool properties that I like talking about. Space-time, turns out, can bend. And actually our best conceptualization of gravity is this one, because it's not, it is less than, say, planets in orbit around stars are moving around them and being held by an invisible string. It's more like they're moving in a straight line in a space that's been curved, because actually what masses do is they curve the space-time, much like the kid on a trampoline, but in 4 dimensions. This actually provides a really good picture of things like black holes. If black holes don't let anything out because they're very massive, so the gravity is very big, why would light care if light particles don't have mass? And we came up with the term of inertial mass and gravitational mass, but really light particles don't have mass. But if you realize that with this conceptualization of four-dimensional space-time, that they don't have to, because the space is bent to some extent that you need a certain velocity to escape. And it's not only that it's mathematically consistent, but the corrections to how time elapses in different frames of reference from special and general relativity are necessary for technologies that exist. So this is a physical reality that we need to integrate. And if we haven't already integrated these corrections into satellite technology, our GPS wouldn't work. So our knowledge of this makes that possible. And that I really like to talk about is the fact that space, actually before that, yeah, I have that's evidence, but thanks to the Hubble Space Telescope and the Space Telescopes, we have images like this one, and this is very beautiful to me, because it is one thing to conceptualize the math of black holes and neutron stars and bending of space-time, but gravitational lensing is a beautiful way to see that. And it's essentially the light between, if the light between you and me is coming, but there is a very massive object between us that is curving the space-time, the light is going to bend as well. And the first time I was making one of these talks, I was reading Psalm 18, and it says that I called upon the Lord who is worthy to be praised, so I shall be saved from my enemies. He bowed the heavens and came down. Actually, there's translations that say he bent the heavens and came down. Thick darkness was under his feet. I'm, of course, not suggesting that the incarnation of Christ is some similar bending of space, time, times eternity, or at least not a gravitational one, because we could detect that kind of thing. But this is one of the things that I like bringing up, a sort of how the science that we see and the implications of it, philosophical and otherwise, at least are things that I bring to my prayer life, but that are awe-inspiring and draw us closer to God, period. So one of the things that I am talking about also is how space can expand and how we know that. We know that space can expand because we measure the velocity of galaxies, and this is actually a phenomenal one to bring to younger audiences, because you can explain how we know that space is expanding with just two very simple physical concepts. One is spectroscopy, so the fact that we can break light into its color, or actually wavelength components, and the fact that we know from what we see here on Earth that different elements have spectra that look different, and that's cool because that's how we know what stars are made of, but also if you combine that with our understanding of the Doppler effect, and I'll spare you the sound effects for that one, but the fact that waves shift towards the blue side of your light, a light wave when something is moving towards you, and the red when something's moving away from you. I mean, you combine those pieces of information and you can measure the velocities of things that are really far away, right? Something's coming towards you, it shifts to the blue, away from you from the red, and then we can measure the velocities of galaxies, and not just that, but determine that actually it looks like all of them are moving away from us, which would make sense if we are the center of the universe. Not that that would be particularly nice, but that is also what you would see if you were sitting on any of these other galaxies. And that doesn't make sense. And it doesn't make sense unless it is the space itself between the galaxies that is expanding. And again, the basis of it is very simple physical concepts, but this is how we reach conclusions of this scale. And this is actually all the knowledge that Father Lemaitre needed to pose what we now call theory of the Big Bang. And it's conceptually very simple. If the universe is expanding, that expansion must have started sometime in the past when the universe was very small. And it's usually depicted on the diagrams like this one, where we've collapsed the spatial dimensions to this plane that looks like a bell, and time is on the x-axis. And it's a beautiful combination of the science knowledge that we have and the things that we know, because a combination of astronomy and astrophysics and cosmology calculations and our knowledge of particle physics and the cosmic microwave background that allow us to see and make sense of it and estimate the age of the universe up to an extent, up to about here. But it does point to like let's say time equals 0 or time equals whenever the Big Bang happened. Some people like using this as an argument for the existence of God. I don't, and I'll tell you why in a couple of slides. But this all comes from, a combination of the different ways that we have to probe at the universe. This is an audience of scientists. I'm sure this is like 40% of your favorite psalm, Psalm 19. But to me, there is a special beauty to Psalm 19, and that it's not. It starts by telling you how the universe tells you something about God and his handiwork. But then it goes into your love for the law. And I think so much about our love for the laws of nature and like that drive to discovery. That's really beautiful. All right, so that's something about time, but God exists in eternity. And it's good to start by talking about what eternity is not, actually. And this is how, if you read the philosophy of time, this is how at least most people treat it. So eternity is not just a bunch more time, infinitely more time in either direction. And to go back to how Aquinas treats it, eternity is simultaneously whole, but time has a before and after, so there's no before and after in eternity, so they're not the same thing. And if you go back to the metaphor of this four-dimensional container, well, maybe you're the universe with all moments of space and time is here in this four-dimensional container, but God is over here, outside of that. And then time being part of creation, it means a couple of ways about how we think about creation and whether we, in the first place, have to justify a moment when it happened or whether it happened in the past in the first place. So you can think of a universe that's consistent with our understanding all the way going back to the Big Bang, and then there's definitely an initial time, but it really doesn't matter to whether there was a moment of creation, because that moment is not in the past, because it's not in time. So time could be cyclical, however else, and it doesn't really mean anything to the existence of God or to God creating the universe. Actually, it gives a beautiful and different meaning, in not different, but I feel like almost scientifically feeling meaning to the fact that God holds the universe in existence at every moment of time. And the Catechism says, to God, all moments of time are present in their immediacy. That also means that when you're praying for something in the future or someone in the past, those moments are present to God in their immediacy. And that's a beautiful thing. And I did say pray for something in the past. I don't want to run out of time, so I won't spend too much time on it, but Jimmy Akin has a phenomenal blog on this, and he says there's one rule: don't pray for paradoxes. And the reason for that is that, well, what that means is don't pray for something that you know happened to not happen, or vice versa. And that's obviously because if you knew something happened or you know something didn't happen in the past, it was either God's perfect will, that means God willed it to happen, or God's permissive will, God allowed it to happen. So just don't pray against God's will. I feel like that's a pretty good principle overall. Okay, so I want to talk about Jesus, because it's all well and good when we separate time is here and eternity is here, but our Lord Jesus Christ has two natures that are not mixed, but he is fully human and fully divine. And that means his human nature must have experienced time like we do. At the same time, I mean, read the Gospel of John, right? In the beginning was the Word, and the Word was with God, and the Word was God, and everything was created through him, right? So the divinity of Christ experiences eternity. And then there's this beautiful sentence in the Catechism that says, all that Christ is participates in the divine eternity, and so transcends all times while being made present in them all. And when I think about this conceptualization of space-time, and Christ being present in moments across space-time, obviously, I think a lot of you will think of this moment. We don't have time to talk about eternity or however angels and saints experience time and or eternity, and there's a lot of cool theology on that. But I want to stay with this moment because that's the whole point. I mean, Christ is the whole point, right? But the sacrifice of Christ and the sacrifice of the Eucharist are one single sacrifice, says the Catechism. So then what you are witnessing in the hands of a priest is how many moments of space-time united with the sacrifice of Christ, like as if the fact that Christ is truly present there wasn't mind-blowing enough. You know? I take this to prayer a lot, probably in very weird scientist ways, but obviously I bring them to prayer a lot, specifically in one place, right? This is why being scientist is such a privilege. Because how many centuries God has allowed us to slowly peel at the gift that is creation, and then in ways that bring us closer to Him. And the fact that we could have an opportunity to share that with other Catholics, that it's so humbling. St. Pope John Paul II said, in Christ, human time was filled with eternity. I have one more reflection before I'm done, because I think we're getting there. Salvation could have taken an instant, right? The fall could have happened, and God could have said, let there be salvation, the end. But it's a story. And creation could have taken time, or no time, or 7 days, but it takes to get to us like billions of years. And of course, we talked about the implication that time is part of creation, but it's a beautiful thing to ponder that time is part of creation, but time is probably also part of the message. And with that, I think time's up. Thank you.